Pre-calc problem 10-32, a company has 200 square centimeters of material to make an open cylindrical container, so it has a bottom but no top. How should they design the can so that it can hold as much as possible? So we know some things about surface area. So this is going to be a can. It's going to have a bottom but no top. And I know that the material that it takes to, don't look at that part yet. Here, let's go like this. The material that it takes to make our can would just be the bottom, which is pi r squared. And then this part right here is kind of like if I roll the paper, right? That's like the shape of a cylinder. And then if I open it up, the shorter side is going to be 2 pi r, right? Like think about rolling this up like it's a label that wraps around the can. Sorry, the shorter side's going to be h, and this is 2 pi r. So this is, or you can just Google volume or surface area of a cylinder, and you'll get something like that. So I just wrote that all down, and then I know that so there's the surface area, and we know that we have 200, the materials that we have to make it is 200. So I think what I did is I just subtracted pi r squared from both sides, and then I divided out, like I wanted the h by itself, so I divided the 2 pi r. Anyway, I just solved it for h. And then I wanted to put that in a I know that when I have to maximize something, I have to put it in a calculator and look at its graph and find the maximum, like the highest point on the graph. But I wasn't sure what to put in my calculator. And then I looked in the answer book and it talked about volume. So, and that's what I'm trying to maximize is the volume, not the surface area. So I got out my volume formula. So we know, you can just Google it. Volume is pi r squared times h. And then this thing's all solved for h, so I can plug it in for h. So there's my pi r squared, and then this is h. This whole thing is h right here. And then I don't know, I did a bunch of, showed all my steps or whatever. But it boils down to this. Okay, and then so that's something I can put in my calculator. So well, in my Desmos calculator, because I want to see where this is now. I think it's going to be a cubic, and I need to see where the maximum is. You know how we have local mins and local max. So I typed that. I just typed that right in. How do I show you that I typed it in? I typed it in just how it was, like that. And then I found the max just by clicking on it. So it was the x coordinate was 4.607. So that is going to be where I'm going to get my maximum volume from, is right there. So R, if I maximize my volume, is going to be 4.607. Okay, so that's going to be my radius. And then to get the height, I already had that the height is 200 minus pi r squared over 2 pi r, so I can plug in my 4.607. And for some reason I got, your book got 4.607, I got 4.606-ish. And then if you multiply, so then we know volume is pi r squared times height. So I got this, your book got 307.106. So, but this is the right way to do it. And those are cubic centimeters. So I should have said. Right. That's it.